Alright, so just continuing that example, since we're dealing with the differential of x, we need an x interval. And the x interval will start at 0. We have to find the intersection of the two functions. So we'll have negative radical x is equal to negative x squared. Let's square both sides. So x equals 0 and x cubed equals 1, so x equals 1. And the interval is going to be from 0 to 1. So the intersection is at x equals 1, the interval is from 0 to 1, and then we can go to the radii. So we have the graph. The axis is the x-axis, and we will find the big radius starting at the axis and going to the furthest part of the region is big R, and that's top minus the bottom, and the bottom is F. For the small radius, we go from the axis to the closest part of the region. That's little r, and that'll be top, which is the x-axis, minus the bottom, which is g, and that's negative x squared. So we found the radii, and then we have to find the area of a washer. The washer is the area of the large circle minus the area of the small circle when we rotate that. So the area of the washer will be the big circle minus the small circle. The area of the big circle is pi r squared, and that r is radical x, pi r squared minus the small circle. If we rotate the green line, makes a circle, and the radius is x squared. Pi r squared, and that's pi big R squared. So that's the area of a washer, and then we'll find the volume of the washer, and that's just going to be squaring the radical. It's just x, and then this will be x to the fourth. So that's just copying the area multiplied by the differential of x, and this is the volume of a washer, and then we'll find the volume of infinite washers, and that's just going to be the integral over the interval from 0 to 1 pi x minus pi x to the fourth dx, and that should give you 0.942 in volume. And let's just review what's happening here. We had this region, and it rotates to make a solid circular funnel type shape. Okay, one more example. The region is f of x equals x squared plus 1, and g of x equals 3. The axis is the x-axis. Okay, that's x squared. Pause the video and try this one. So we have the parabola f of x, and then horizontal line at 3. We need to find, we need to decide on, should we use vertical or horizontal rectangles? The vertical rectangles will always have the same top and the same bottom, so let's use vertical. And that means we'll need the differential of x. We'll do everything in terms of x. That means we need an x interval. And the x interval is going to be when x squared plus 1 equals 3. When x squared plus 1 equals 3 will give us the intersections. X squared equals 2 and x equals positive or negative radical 2. So this is negative radical 2 and that's positive radical 2. Let's find the radii. So we'll look at the graph. Rotating around the x-axis. And we'll find the big radius, which is from the axis to the furthest part of the region. The length of that is top, which is 3, minus the bottom, which is 0. The small radius from the axis to the closest part of the region, small r, and that will be top, which is the parabola, x squared plus 1 minus 0, the x-axis. So we have big R is 3, little r is x squared plus 1. And let's find the area of a washer. That will be the large circle minus the small circle. So we'll have the large circle with the large radius, that's pi r squared, minus the small circle with a small radius. So that's 3 squared, lowercase r, x squared plus 1 squared. All right. Volume of a washer is the area times the differential of x, and that's where we have the large circle with the small circle cut out, and then we have a thickness of dx. That's why we need to multiply by dx to create a volume instead of just having the surface. And let's do the volume of infinite washers. That will be the integral from negative radical 2 to radical 2 of all of this. And that should be 52.130. All right, and we'll stop there.